Hi everybody. I'm doing question 3 on page 511, and what the question is asking us to find is the thickness of our soapy film, our soapy film. Now what they do is they give us the index of refraction of this film, and they also give us the wavelength of the light that reflects off of it. Now because we know we can see the light, we know it's constructive interference. So we just have to figure out if this light goes through any phase changes, and that determines which one of these equations we'll be using. So I made out this cute little map that we'll use to figure it out, and how you guys can figure it out on any other question, if you don't have Mr. Keen as a grade 12 physics teacher to explain it. So what we're going to do is we're going to use this to represent the direction of light. So if there's a phase change, it'll flip around. This is meant to show, it's supposed to act like a sine wave that we'll be seeing, but we just keep it as a bump for the sake of simplicity. Now we know it goes straight down on the normal, but we draw it as an angle just for the sake of convenience, so no, it's not just all on the same line. That'd be ugly. Okay, now for the first reflection, we see that light is going through a fast medium to a slower medium, the index of refraction of air being 1, and this one being 1.35. So we see that there is no phase change. And then the light continues to move downwards, stays the same on transmission, and then it bumps in with the glass. Now again, fast medium, slow medium, so there is no flip. Keeps on traveling upwards, and it stays the same. So we have constructive interference, which we already knew, but here's how you prove it. And we have either no phase change or them both going through the same phase change. So that means we'll be using this equation. Hit my phone. We'll be using this equation. Now, 2t, we know that lambda is 600 nanometers. And then n here has a value of 1 because we're using air. And then that all goes over 1.35, which is the index of refraction for the film. The thickness we get this. The answer from this is 444.44, and that those decimals go on infinitely, at least on my calculator. And then when we do all the calculations, we divide 444.44 by 2. The thickness we get is 222.22. That again goes on infinitely in nanometers. And if they want it in meters, it'll be here. And that's how you figure out the thickness for this specific question. Thank you for listening.